all have in common the fact that numerical simulation is done by using partial differential equations and numerical methods to solve them. And this allows us to go to different physical or engineering areas.
The applications that mathematics can have on industry and on our understanding of the environment are boundless, and that is exactly what our next guest, Professor Alfredo Bermúdez, will be talking about in his lecture entitled Some Case Studies in Environmental and Industrial Mathematics. Alfredo, thank you for joining us.
Thank you.
Could we start by talking about why you're bringing 4 very different case studies to ICM 2019?
I try to emphasize some things, in particular the fact that mathematics is quite transversal. And the other thing I like to emphasize is the fact that industrial or environmental mathematics, that is true applied mathematics, are also interesting from the, let's say, academic point of view. So the outcome is not only the industrial outcome, the demand from the companies, but also articles, papers, that is very important in the career of a researcher.
So maybe we could talk about those 4 different case studies. The first one is environmental fluid mechanics.
In environmental fluid mechanics, I try to simulate the evolution of the pollution in a sea area in order to optimize the wastewater treatment systems.
And what about in the gas transportation network?
Well, simulation and optimization of gas transportation network is an important issue in the field of energy. The idea is that you have some compression stations in the network. These compression stations are needed to push the gas because the gas is dropped in pressure because of friction against walls. So the idea is how to manage the network in order to reduce the cost.
And I think the third case study that you looked at was testing of car parts using magnetic nanoparticles. What were you looking for there?
In this case, it's a demand from a company manufacturing car parts, in particular crankshafts. And in order to determine the existence of some brakes, surface brakes, one can use the so-called magnetic particle inspection to simulate the magnetization and demagnetization of this piece by using mathematical models coming from Maxwell equation in electromagnetism.
The 4 case studies that you are discussing are all very different from each other. Do they have anything in common?
Yes, in fact, all have in common the fact that numerical simulation is done by using partial differential equations and numerical methods to solve them. And this allows us to go to different physical or engineering areas.
The case studies have really shown how diverse applied mathematics can be. What advice would you give to any of the young mathematicians that are here, the young researchers trying to pick an area to focus on?
You also need to know other disciplines. You need to know fluid mechanics, electromagnetism, chemistry, sometimes something in medicine. So the interesting thing is mixture, this mix between mathematics and other disciplines. There is a field of research and application very important.
Well, Alfredo, thank you so much for joining us. It's been great to talk to you.
Thank you. Thank you.